All right, let's talk about artificial intelligence and machine learning. And I want to be super clear right from the start. This is not just another software update. This is a fundamental revolution, a complete sea change in what computers can even do. So let's dive in. You know, this quote from Stanford's Steve Blank just nails it. It perfectly captures how huge this moment is. It feels like we're back in the 1950s trying to explain the internet to someone who's never even seen a TV. We're right at the beginning of a totally new era. And this isn't just some theory. The people with the money are betting big on this future. We're talking hundreds of billions of dollars in capital pouring into AI and machine learning. When you see that kind of money moving, you know this is a real game changer. There are massive economic and strategic stakes here. It's become a global race, and the pace of innovation is just staggering. And this chart right here, it just drives that point home. All that investment is fueling an absolute explosion of new ideas. The number of AI-related patents filed in 2021 was over 30 times higher than it was just a few years earlier in 2015. Think about that. This isn't a slow and steady climb. It's a rocket launch.
Okay, so we've all heard the buzzwords, right? AI, machine learning, deep learning, neural nets. It can sound like a whole lot of confusing jargon. But don't worry, we're going to peel back all those layers and make it crystal clear.
The absolute easiest way to think about all this is like a set of those Russian nesting dolls. You've got the biggest doll on the outside, that's artificial intelligence, the whole big idea. You open it up, and inside you find machine learning, which is a specific way to do AI. Then you open that one, and you find the smallest doll, deep learning, a really powerful, specialized technique inside of machine learning. Let's break each one down. First up, artificial intelligence, or AI. This is the big, overarching dream that got started decades ago. The whole idea was, can we create machines that can think, reason, and solve problems the way humans do? It's not one single thing, but this huge field of study. Now here's where it gets really interesting. Look at that word, learn. Machine learning is the engine that's making all the cool AI stuff happen today. Instead of a programmer sitting down and writing out every single step-by-step instruction, you give the machine a ton of data, and it literally teaches itself how to find patterns. And finally, we get to deep learning. You can think of this as a supercharged version of machine learning. It uses a structure inspired by the human brain called a neural network that has lots and lots of layers, and that's the deep part. This structure lets it learn incredibly complex patterns, which is why it's so ridiculously good at things like understanding what you're saying or finding your friend's face in a photo. Okay, understanding those definitions is so important because it brings us to the biggest idea in this entire explainer. Seriously, if you have one aha moment today, this is going to be it. It's the massive shift from coding something to learning something. For the last, 75 years or so, this is how computers have worked. A human programmer has to think of every single possible rule and write it all down as code. The computer is in the middle, and it just follows those instructions perfectly. It's basically a very, very fast and obedient calculator. But with machine learning, the whole process gets flipped completely on its head. Humans don't write the detailed rules anymore. Nope. Instead, we just feed the machine a mountain of data, say thousands and thousands of pictures of cats. The machine then chews on all that data and learns the rules for itself. It builds its own understanding of what a cat is. So here's the bottom line. A classic computer is told exactly what to do. A machine learning system discovers what to do. One is all about following logic that a human wrote. The other is about finding patterns that no human could ever spot. And that difference right there, that's what unlocks a whole new universe of problems we can solve. So you might be asking, why is all of this happening now? Well, it's not because of one single breakthrough. It's actually because 4 totally separate trends have all hit a critical point at the exact same time, creating this powerful, self-reinforcing cycle. First, thanks to the internet, we have these enormous data sets to train with. Second, the algorithms, the learning methods themselves, have gotten so much smarter. Third, tons of this code is open source, so people can share and build on each other's work instead of starting from scratch. And finally, we have the raw computing horsepower to actually run these massive calculations. You put all 4 of those together and boom, you've got a revolution. Okay, enough with the theory. What does this stuff actually look like out there in the real world? Well, the truth is it's already everywhere. You're probably using it every single day without even thinking about it. Every time you talk to Siri or Alexa, that's machine learning. When your phone automatically tags your friends in photos, That's ML. The autocomplete that finishes your sentences, the real-time language translation, the recommendations Netflix gives you, even those crazy AI-generated images you see online, it's all powered by this new way of teaching computers.
So if AI can do all of those little things, you can just imagine the kind of impact it's having on a much bigger scale. This technology isn't just changing our phone apps, it's fundamentally reshaping entire industries and, yeah, even the world of national security. Take healthcare. AIs are now analyzing medical scans to find tumors, sometimes with more accuracy than a human doctor. In the car industry, it's the brain that powers self-driving vehicles. And for businesses, it's a total game changer, helping them optimize massive global supply chains or predict what you're going to buy next. The source material also points out that these same powerful technologies have really profound applications for national security. We're talking about everything from automated surveillance and facial recognition to coordinating autonomous systems like swarms of drones. AI can also fuse together unbelievable amounts of sensor data to find hidden targets, and it can even be used in information warfare by creating ultra-realistic deepfakes. All right, so as we look to the future, it's really important to be excited about the potential here, but also to be realistic about what AI is today. It isn't magic, and there's still a whole lot of things it just can't do. For all its power, today's AI has basically zero common sense. It's great at finding patterns, but it doesn't really understand cause and effect, the why behind the data. It can't be truly creative on its own, it can't decide on its own goals, and it struggles to take what it learned in one area and apply it somewhere else. Fixing these things, that's the next great frontier for the researchers. And that really brings us to the final and most crucial point. For 75 years, the computer revolution was all about what we could program a computer to do. This new revolution, it's all about what we can help them learn, which leaves us with the biggest, most important question of all. In this new age, what do we want to teach our machines?